Welcome back to Minecraft. I've rebooted my PC so that it's not as crazy as the last episode. But yeah, Demon and Malinka are here. Hello.
Hello.
Cool. So yeah, recap. Last episode we built pretty much this setup here with the mob spawners. Currently they work. If I put in a mob spawn egg into the auto spawner, it will just work. And close this door. That's working. But right now we have no control over turning them off. Like if I put a spawn egg in it, it's just going to be on and it's just going to be a bit crazy until we can get in there and turn it off. That's no good. And one thing I wanted to say is that the reason we've got 9 of these as opposed to one mob spawner with an egg being transported in and out of it is we want to, two reasons. One, it's cooler this way, and the second reason is if we really wanted to, we could have Enderman and spiders going at once, for example, which we can't do under normal circumstances. So yeah, these aren't designed to be on all the time, as it happens, because that would drain our mob essence and power really, really fast. Because actually, auto spawners and grinders use up a lot of energies and fluids, so
We just don't have it.
So Malinka, do you want to take us through the idea of how we're going to control this? And
Okay, that's actually quite easy. We're going to use computers. I'm done.
Awesome. Best episode
No.
ever.
It's gonna actually be a bit more interesting than that.
yeah,
And it took a bit of programming to get it done. How do you want me to explain it, Fire? Show it off on test setup, or show what's happening here? Or what we're going to do here?
whichever's going to be easiest to understand for the audience. So the test setup might be
Well,
good.
let's use the test setup, show it off, then we'll do a bit of cable work and show off the finished product.
Yeah, I think so.
Let me run the programs then.
Okay. We should probably explain some of the setup over here, maybe first.
Yep. What I first wanted to do is just check if I could have redstone signals respond on certain color codes. So if you look at the lamps here, the 3, they have white, orange, and
Blue.
what's the third one again? I always forget that name. Magenta.
Magenta.
It's blue.
Yep. No. Yeah, the lamp itself is blue, but the color connection over here is magenta.
Oh, okay. Yeah. So this is redneck cabling
Those-
from MFR actually, by the way. And to switch the colours, you can see this band here. If you right click with an empty hand, it will change the colours of the band, I think. So.
No, you need to use a crescent hammer or omni wrench or something like that.
Oh, okay. Actually, I could possibly be able to show it without ruining things too much. So by right clicking here, it changes the colour, and I'll have to get back to magenta.
Stop.
That wasn't magenta. That was purple.
From white, 2 more.
1, 2. There we go.
That's it. Yep.
So that's
The fourth
let's
one
choose that.
is a cable directly into the computer here. Fun fact, a computer cannot get a color signal. It's always like this. It just simply hits the computer and it's done.
Yep.
You actually have to use the computer to read out what's coming in and correspond to that. Why are we using computers? Well, we want multiple things happening once we activate. Fire has shown you those monitors outside in the cages, which will actually light up once we activate a cage. As you can see, this monitor is currently set to red, which would mean the monitor is turned off, or the cage is turned off. And this lamp on top of it is turned off as well. Why 2 signals? Well, the monitor will show us that the cage is turned off, and this will be the redstone signal actually turning off either the auto spawner or the tesseract.
Yeah, I'm
Probably
gonna
the tesseract because we can reach it easier.
Yeah, I'm going to come out here just to show what those 2 things
Yeah.
relate to. So the monitor that is red over there, that's the equivalent of this monitor down here, and the lamp is the equivalent of the auto spawner in this situation.
Yeah, that's the best way to explain it.
Cool.
Some of you might actually realize what code is used to show these buttons. Thank you, Direwolf 20.
Um,
I've used this old button API to generate the buttons. Just made it a bit easier.
Yeah, you can download it if you look up on Button API on YouTube with Direwolf20. You'll be able to see a video that he's made and download his Button API, which we use quite extensively. It's mostly to save us work. He's done the work, like we said the other episode when we were setting up the Essence stuff. If someone else has put in all the work and they give you a code, a pastebin code, they put the pastebin code for you to use it. Like, that's why they do it. They want you to use it. We'll give our own pastebin codes probably of these finished products, but just bear in mind you also need to download the Button API and from Direwolf20 and our code together, and you'll be able to use our mobs on demand system too. So
same with our Nexus code from a few seasons back. It's also on pastebin somewhere.
yes, that's correct. So yeah, we put them there for a reason, same as Direwolf, so we'll use them. Go on then, Malinka.
Yep. Well, for now, you can see 9 buttons, though the monitor isn't big enough to show all of the right side. But that doesn't really matter, because only the first 4 buttons are connected. The Blizz button corresponds with this white lamp here.
Yep.
Pikmin for the orange lamp. Wither for the blue lamp with magenta code. And last but not least, Enderman will correspond with this computer. Fire, would you do me the honor and press, for example, well, at least one of the first 3. Don't press the Enderman yet.
Okay.
And show off what happens.
So as you can see, I push the button and the button turns green, but so does the lamp. And then we've got a timer on here. What's it set to at the moment on the timer? Is it 3?
Nope. That's why I want to show these first. These lamps just keep turned on as long as the button is turned on.
Oh, okay. And if I right click
So
again,
that's what
that will turn it off.
it'll turn off.
Yeah.
You can use any combination. For example, just Pikmin together with Wither will show off both lamps.
Yep.
Now this won't work perfectly for our cages. Why? If we turn on a lamp like this, for example the cage, it'll just keep on going, draining all our power, mob essence, and everything else we're putting into it.
Mm-hmm.
Not a good thing. So we needed something that could turn itself back off again. Now for that, you need a bit of programming tricks. You need to do parallel programming. You need to keep this button API going, corresponding to turning it on and off. But
Yep.
what you also need to do is keep in mind, when turned on, a timer needs to start running, which will turn this signal off again after a period. For example, when we forget to turn off the button, or we just want max output, things like that.
Yeah, so because we're running parallel programs, this version of computercraft isn't capable of doing parallel programs. Actually, the new one, which is coming in 1.7, does, but this one doesn't. And so to do parallel programming, we're actually using 2 computers. That's basically how we do the parallel.
No, that's not really it actually.
Oh, go on, and you can explain it.
That has more to do with keeping in mind that this one we just want control of this board. And the other computers will take care of their individual cages and run a timer.
Okay.
It's actually two parallel programs working at the same time.
Cool, should we show a bit of code?
This one will be. Yes, I can, but first let's show off what happens. And then I'll
Okay.
show you how the code does it.
Yep.
If you will take a look at the lamp and the monitor here, Fire.
Yep, I see it.
I'll be pressing the Enderman button. It's going to be quite fast. I've got the timeout set to 5 seconds now. So if I click Enderman, this will all turn on, and in 5 seconds it will turn itself off again.
Fantastic. Yep.
Yep. And the fun fact is, that's why there's a second cable, this computer will tell that computer to turn the Enderman button off as well.
Cool.
So how do we do that? Well, let's terminate the programs to show a bit.
Okay, which computer are we starting off? This one?
Main computer.
Okay.
Let's see, where's the edit? No edit? I'll talk to myself then.
So yeah, right at the start here you can
First-
see us loading the button API from Direwolf, so that's what that first part is.
Yep.
Go
The
on.
input and the output sides are basically the sides on which I will be sending the redstone signals. Output side, So one on the right, which is basically the input for the lamps and the computer which will handle the cage. Input side is where the other computers will tell this computer that they've turned off their cage. There's a monitor as usual, which we clear when we start up. And from here on, it's gonna start being a bit interesting. What I've used is bit coding. Have you ever worked with bit coding, Fire?
No, not at all. This is new to me.
Ah, cool. For those who do programming for a living or just for fun, they probably know what bit coding is. Basically, it's what's... Yeah, it's difficult to explain if you don't ever see it. Maybe it's better if I just type it a bit. First bit, value 1, which is basically 2 to the power 0.
Okay.
Value
You lost me
2,
already.
4. Ah, come on, yeah, not even a bit of math, Fire?
Okay, no, I'm good. You're right.
But basically this is how a computer works. It works with bits. And every bit will have its own corresponding full value. 1 is 2 to the power 0. That's for the first bit.
Welcome to the number file with Malinka and...
Yeah.
Sorry.
Anyways, it's a lot of math which will basically respond 2 to the power. Some value will have the corresponding bit above it. Which in this case would be bit value 1, 2, 4, 8. And as you can see, it's actually a doubling of value every time. Which goes on to, for the last color, is actually this value. 7, 6. Oh, that's a typo.
Okay.
The color black actually corresponds to this number. 1 is white. Here we've got orange, magenta, light blue, yellow, lime, and so on and so on.
And that's just the
Most
way
of this
they're
can be found on the...
coded in the computercraft, isn't it? So that's why it's like that.
Yep. Yep. But what I do is, on the signal I send, I basically count up those values to tell the computers which colors are active. For example, white is 1 and yellow was 16. Oh, sorry, 16. So if I send the signal 17, it'll know that it's 1 and 16 that are turned on.
Pretty
Hope
smart.
I'm not losing you, Fire.
No, I'm totally with it. I don't know if you've lost any of the audience, but I'm totally with it.
Basically that's how bit values work in a nutshell. So I've got 3 functions here. One basically checks a value if one bit is turned off or not. Returns a boolean on that. This one takes a value and turns a bit on. If it's turned on, it'll just stay on. And this function will turn a bit value off, or lets it stay off if it's already off.
Okay.
Basically 3 mathematical functions that I use to manipulate the signal coming out of this computer. For those who've already looked at the button API, this will look quite familiar. This is just basically setting the buttons.
Yeah,
The
that's
bliss button, pigment,
all
wither,
set up.
and so on
Yep.
and so on. Yep. In the end here, the false... No wait, let's start in front of that. This is the function that will turn... that will be activated once you press the button. This is the basic value for how to show it when starting the monitor. In this case, all red. Turned off, that's what false represents. And last but not least, the coordinates for where the buttons are. And now we come to the part where, well, for example, toggle bliss. Well, let's go to that one. What does toggle bliss do? Once again, bliss corresponds to bit value 1 or color white and has the button called bliss. That activates toggle mob with those 2 values. So let's go to toggle mob, which is just above it. As you can see, bit value and mob buttons are the 2 values coming in, and it does the first bit check with it. It checks if the current color is already active. If yes, if the color is active, then it needs to turn off the color. That's why it's called in clear bit. And if the color is not active, it actually needs to activate it. Simple check to see what is happening actually. Once I've manipulated the bit value, I send it out of the output side of the computer, and toggle button, basically just switching it around from red to blue, from red to green, or green to red, depending on the current state of the button.
Mm-hmm.
This will happen for every type of mob, as you can see,
And each of the values
with
next
the
to them.
increasing bit value.
Yeah.
Yep. Easy enough to follow. Let's see, that's the last one.
Okay.
This is basically the function that just waits till someone touches the monitor. Basically a button checker.
Yep.
It waits on the monitor touch event and then calls the button API till with the coordinates that you've clicked. That's how it knows which button to activate. For this part I'll actually have to see where I can best start.
Okay. I'm just going to say while you're
Sorry about
sorting
that.
that out, right, you are an absolute legend. I didn't realise it was this convoluted when I asked you to do it, but oh my god, you are a legend.
I'm so glad he did it.
Yeah. Go on, mate.
Let's start at the bottom actually, because this is where the program starts. That's easier to explain the parallel programming in it. First, it calls to create buttons to create the buttons on the monitor. Reinitializes the output towards the cages, in this case setting all the cages to turned off. We set the heading above the buttons, in this case mobs on demand. And this is where the magic happens. Parallel programming is quite easy in Lua. You've got parallel.waitForAny or waitForAll. What does waitForAny do? Well, I think we've actually used it before in one of our programs, but I'm not sure. But I'll explain it again. Basically, I've got two functions in here, waitForSignal and getClick. Both get activated at the same time with waitForAny, and as soon as one of them finishes, the other one gets aborted. So basically, first come, first serve.
Okay.
If you use waitForAll, it'll wait till all the functions are finished in this list before it goes to the next line, which in this case would actually be just waiting again on whichever finishes first.
Okay.
Well, getClick is easy. That's the one I've already shown, and that just waits till a monitor event happens and handles the monitor event. The other one is the interesting one. That one waits till one of the cages tells it, I'm done. You didn't tell me to turn off, so I turned myself off. So, what do they call it? waitForSignal. It'll sleep for 1 second to make sure that it doesn't go crazy. If you don't put sleep in your loops, it'll just keep on going on nearly infinite speed, as fast as the server can handle it, which will just ruin your server. So don't forget your sleeps at the correct points, or you'll just crash your server. Have we actually done that once, Fire? I can't remember, maybe a few servers back.
Yeah, I think I've done it with Aussie, I think, when we've done... yeah.
Anyways, what does it do? It waits for a second, then it reads the input side, which was... Fire, can you follow me for a second?
Yep, sure.
It's the cable in the back here. So we've got on the right is the input, the input for these and the output for the main computer, and the cable in the back here is the input side for the main computer.
Yep.
Let me know when you're back in the program.
I'm there.
Well, this is a bit of lazy programming I've done. I could have done this in a loop, but, well, yeah. Basically, it reads out the signal coming back from the cage, just to check which cage is turning itself off. It'll check for every bit value if that cage is the one telling you to turn it off. So it checks on the same bit value that's turning it off. In this case, white, orange, magenta, and so on. And then calls the procedure turn off signal to actually turn it off, the button at least. So back here is the turn off signal. First it'll clear the current caller again. For example, if the yellow light tells us to turn itself off, it'll turn off the bit for yellow. Renew the output without the yellow, and last but not least, check which one it was and switch the button by here getting which button it is on certain values, and then here once again calling toggle button.
Yep.
And that's basically how the whole program works. It's a lot of work to keep it going, but well, yeah, it works.
No, it kind of makes sense. I mean, there's a lot there to keep up with, but you know, essentially you're handling the a button event is sending a bit value, or in other words, a color value. So sends it off to either a lamp or a computer, as in this one over here.
Yep.
And then once it gets the signal back to say it's finished its stuff, then the computer reads, oh, this color, this bit value has finished, turn the button off. And although it's a lot of code in there to do it, that's pretty much what it's doing.
That's the general idea for it, indeed.
Yeah.
So, the second program. Luckily, a lot simpler. First value is how long it waits before it turns itself off. I've got it set to 3 seconds, but for the cages it'll probably be how long, Fire?
I think we were talking about 3 minutes, so that's 180.
So that would be 180. But for this I'll keep it on 3 just to show something off. No wait, 10 is actually better. I'll show that in a second.
Yep.
Local color, once again the bit value. 8 being light blue, which would be the 4th button.
Yeah, so that's the equivalent of setting the color here. Instead of setting the color here, what we're doing is setting the color by putting the local color equals 8, but it's the equivalent of setting a color on a RedNet cable.
Yep. This one I'll come back to later, shutdown. Once again I need to set which side is what. Input is coming from the left, output is in the right. Redstone signal is on the top and the monitor is on the back. This one is familiar. Here I also use a has-bit code. And for this one I'll have to look where it's easier to start. Well, this one is easy enough to show off. This set monitor value, basically if it's true, in other words if the cage is turned on, it'll set the background color of the monitor to green and color it all green. If the monitor value is set to false, it'll color the monitor red. Quite simple, nothing special about it.
Yep.
So, where do I start with this one? I'll have to check for a second, sorry.
That's alright.
I'll start at the bottom again. On startup, output side needs to say, I'm done. Oh, actually the redstone side. The lamp will be turned off on starting on this computer. Same with the output. Set the output to 0. Monitor, turn it red. Basically that's our whole initialization. I hate that word. And then it starts a get signal. What does get signal do?
Gets the signal.
It'll try to get an input from the input side.
Yeah, cool.
It'll wait for get the signal from the input side indeed. Check if the current color is turned on. And if so, starts these two programs. Set signal on and set timer.
Yep, so that's your parallel
Yep.
function in that. Yep.
I'll show set timer first. That's easy, that's the one above it.
So if I understand this correctly, the reason why you have a parallel function in there, of which it turns it off under any circumstances, is one circumstance is if I come in and manually switch it off before the timer's up, and the other is the timer's finished. That's the two.
Yeah, that's basically it.
Yeah.
So on the top side we set the max wait, which is set to 10 at the moment I think. This basically sleeps for that many seconds. And then starts turning off the signal. It sets the signal to false. Tells the input side that it's in a shutdown mode. That's why the shutdown is here. Basically as it's shutting itself down it can't accept a new signal. To make sure that it's not confusing itself. That's why I've got a boolean around that. I'll show in the second procedure what shutdown will do there. On the output side, we'll set the local color, as in this cage it's turning itself off. That'll go towards the main computer to turn off that button. Sleep for a second, and turn the output off again, so it doesn't keep the main computer turning itself off again. That won't work for I think, Demon.
Yeah, it doesn't matter.
No,
We've got no
unfortunately.
mob spawns in the area anyway, Demon, so don't need to sleep.
That's true. And then we've got set signal on. Basically, once again, it sets the set signal to true, which turns the redstone signal on and the monitor to green. Then it'll start waiting. What will it wait on? Well, it'll check the input side again and see if we haven't turned off the button. But if we did, it'll stop waiting and set the signal to false again. And here we've got the return of shutdown. Basically, once it's in shutdown because of the timer, it will not accept the signal from the button.
Mm-hmm.
It's a bit difficult to explain why that needs to be, but it would mess up the states. If you can follow that, actually, Fire.
I can't. It's okay. It's fine.
Okay, it's actually quite difficult to explain. You've got the input coming in at the same time as it's turning itself off. To make sure that those two events don't conflict, this event will turn itself off while the other one is active. That's basically what's happening.
Okay.
Better than that, I can't really explain it, I think, at the moment.
No, that's fine.
But that's actually the whole program. This one's quite small in comparison.
Okay. Well, in comparison to what? Because our other programs
This one,
have
and the
been
Nexus
easy.
code, and all that.
I'm not sure.
Pretty much anything everybody else does.
Okay.
No. This
So
is, let me check quick.
Okay.
Direwolf's button API is in size comparable, I think, just between these two.
Okay.
And
Well-
his main programs are a lot bigger.
Okay, so basically these programs are pretty much ready to go. They're not installed in over there, but they're ready to go, right?
Yep, they're all good to go.
Okay, you've got one more task to do before we wrap up this episode, Malinka.
Which is?
Right, starting with this PC that I'm on right now, which is the main one. Can you paste bin put this
Yep.
code, please?
Okay, paste bin... What was it again? Can you remember? Just put, I think.
Yeah, and then that's it.
Name.
That's it, and I think that's right. I don't think you have to. There we go. So here's
There
the
we go.
paste bin code for the main part of this program. The button API we said you can get from Direwolf's channel, so you'll need to get that as well. So that's this one, and one more. This is the computer here. Now bear in mind, when you take this code for the monster cage, is you'll need to download this to however many monster cages you've got. So in this case we've got 9 of them, but you know, if you've got like 4 or 10 or 12, you'll need to get this code before you paste bin put that code actually. Do you want to edit the monster cage program just quickly for me?
2.
Yeah. So the one thing you'll have to change when you do grab this code is the local color for each one, going up as 1, 2, 4, 8, 16, you know, per color as you set it. So make sure that when you grab this code, that's what you do. Yeah, now if you come out and you can paste in code that, but yeah, just remember you need to grab this code help for each cage that you need.
Ugh, I'm not binging.
There we go, and there's your
There we
code
go.
for the monster cage. So yeah, if you want to run these programs yourself, it shouldn't be too difficult to grab these programs off of Pastebin. And installing this over there, we're going to do next episode because, to be honest, Malinka, not everyone is a computer
Yeah.
programmer, and some people would have been like, that is over my head and turned off. So computer programmers, I'm glad you've stopped and watched, and I hope you've enjoyed it. If not, then if you've stuck around, then next episode is where we install it, and you'll be able to see that as a separate one. So I understand if people have stopped watching it, that kind of makes sense to me. But thanks for Malinka, especially Malinka, you're a legend for this, and Demon Reaper. We'll see you next time.
Bye bye.
Bye bye.